And this is a typical example of what you might get in an exam. This question says the ciphered message NACU was produced after ciphering a plain text message. So we had a plain text message was encrypted using this matrix 3645, and it produced the ciphered text NACU. I don't know if we do this last week? No. All right. So find the, okay, normally they don't have to ask you in two parts, 1 and 2. But in order to decipher this message, you need to find the inverse of this matrix. First, you need to find, does it have an inverse or not? How do we know? How do you know if a matrix has an inverse or it does not have an inverse? Okay, so if the modular inverse is a number, an odd number between 1 and 25, except number 13, because number 13 is not co-prime to 26, it divides by 26. But all other numbers do not divide by 25, or 26, sorry. That's the modulo. So that's how you'd know. Sometimes you're given an exam question, say, okay, this was ciphered by this, decipher it, and there is no inverse for it to decipher. So you need first to get the determinant and find out whether it has an inverse or not, and then create the inverse matrix, and then multiply the inverse matrix into the letters NA, in this case 2 by 2, so it takes 2 characters each time. If it was 3 by 3, take 3 characters each time. And multiply that matrix into 2 characters N and A, and then multiply it to CU, and hopefully it should give us back the ciphered message. So why don't you start? And here are the steps how to start. You make sure that all values in the matrix are in the modulo 26. That means all the values in that matrix are not negative, they're not below 0, and they are not above 25. And then calculate the determinant of the first matrix, this matrix. So we get the, how do we calculate the determinant for this matrix? Any idea? How do you find out the determinant for a matrix? Yeah. Multiply them like that and then add them together? No. Subtract. So it's 3 times 15 minus 4 times 6. Right? And then the next step, make sure that the determinant A has a modular inverse. So if it's a number that is not odd, then it won't work. If it's 13, it will not work. And then calculate the adjugate of A. So you also have to change. What's the adjugate of a matrix? Okay, you have to swap the 2 numbers, the 3 and the 5, change their locations, and change the sign of the other 2 numbers. If they're plus, make them negative. That's the adjugate matrix. And then multiply that newer inverse determinant into the adjugate matrix, and you should multiply the adjugate of A matrix into the modular inverse, and hopefully that you should get the inverse matrix. And to know it is the inverse matrix, you need to prove that it is the inverse matrix. So, start ahead, guys, and we will work it out eventually. So today is just decryption. If you don't have a paper, I'll give you a piece of paper. Don't sit down. This is for those who do not know that. All right, I'm going to start working in it as well, so you work away and... So we start with the determinant of A. Minus 9. What's minus 9 mod 26? This is equal 17 mod 6 mod 26. Okay, so the determinant is 17. So does this matrix have an inverse? Okay. So if the determinant, which is 17, it's odd and it's not 13, then this determinant has an inverse. Now you have to work in finding that inverse. So what's the next step? So we finished step number 2. We got the determinant, modular determinant is 17. Now make sure that A has a modular inverse of 26. It has. Calculate the adjugate of A. First, you need to find the inverse of. There it is. Look for this 17. The inverse of 17 is 23. Yeah. Okay, guys. So here are the steps. First, you find the determinant of the inverse of the matrix. That's 3 times 5. Now, this 17 is the determinant for this matrix. We're going to get the inverse of this matrix, then we have to get the inverse of this determinant. The inverse of 17, you can get it from this table. There's only one number that if you multiply it into 17 and multiply 26, the result is 1. So, the inverse of 17 is 23. So now we have to work out, we need to get the adjugate of the matrix. What's the adjugate of the matrix? 3, 6, 4, 5. To work out the adjugate, all you have to do is reverse these two, 3 and 5, reverse them, swap them. The signs of those two. So this is plus 6, change it to minus 6. Get to the matrix. Now we have the adjugate and we have the inverse determinant. Multiply them to give us the inverse of the matrix. Okay, did anybody get the result of this? And this equals, this has numbers outside the 26 range. The mod. So I have to multiply 26, yeah? We're going to mod this by 26 and that and that and that. What's 115 modded 26? 11? Yes. Thank you. Okay. Woo. Now, I don't know if this is correct, but this should be the inverse of that. Now, prove it to me. Make sure it is. Check it. Is that the inverse of this? All right. It looks okay, does it? It's not finished yet, so let's finish it in its best or easiest format by 26. All right. That means this one is the inverse of that one. Now we have the inverse matrix. All we have to do now is decipher the message. That means take this message, take this matrix, what's the original question? What are the characters? NaCu. So NaCu are according to this one, N is 13 and A is 0. So that's N. I'll just write N here somewhere. It should not be written, but I'll write it. What's that? 13, is it? Oh. And A is 0. And what's that? And 12 times 13. What's 12 times 13? 144, 1. Okay, what do we need to do after that? Woo, that's unusual. Huh? Okay, this is unusual, but yeah, this is the right one. Yeah? Let's do the next line. And 12 times 2 is 24, and 17 times 2 is 340. 340 and 24, 364. Thank you. Are you the other calculator? The other number is 0. Whoa. So the ciphered message was NaCu, and it was brought to NASA. Okay, so that's why we can't use very long messages. It takes you too long to. Okay? Good. Now give me an example now you do on your own. Okay, so I don't know if this was correct. So if this is the actual solution that was expected. So remember that table there will not be available for you in the exam, that table. You'll need to produce it yourself or learn it or do something. This is the one that gives you the inverse. And remember, it's only half the table because all the others are duplicated. I will provide this table, the grid. Okay, so that's one example. And this is how to actually encrypt this, how This is how it was encrypted using the 3645 matrix, encrypting the word NASA. Sometimes you're given a number, this message is saying encrypted. But it's unlikely because it's very simple. Because in this case, you don't have to, unless if the matrix has numbers in the minus or bigger than 26, then you have to mod 26 them. You have to change it into mod 26 and then get the value of the characters. N is 13, A is 0, and multiply this matrix into 1360, and that's what we got, 13020, and that's NACU. And then we deciphered that. First, to get this solution right, you get a pen. Don't use your laptop to calculate it. Don't go to a website with a calculator that will do it on your behalf. I'm going to go around to make sure you're not on any calculator. Okay, this is a pen. I hope it works. Yeah, it works. Beautiful. The solution has to be right as well, not just finished. You finish. First to scream they're finished or shout finished, they get checked first. Next time we'll get you. Okay, you're almost finished, everybody, so keep going. Next one is just going to give you one column transposition cycle. That's another little problem. It always causes problems to people. Go to the next one. Okay, guys, you should have. You needed to calculate the determinant. The determinant 7 by 2 minus 1 times 7, and that's 7. And it's a number between, it's an odd number between 1 and 25, and it's not 13, then the matrix has an inverse. So first you get the inverse of the determinant, and 7 works out 15. The inverse of the determinant. I got 15, you need the adjuvant of the matrix, which is swap these two numbers, 7 and 2, change them, and change the sign of the 1 and 7. So here they are. So the adjuvant, we just swap those two numbers. The 7 and the 2, they turned into 2 and 7. And the 1 and 7 turned into minus 1 and minus 7. Okay, we change the minuses, we mod them to get rid of the minus 7 and minus 1, and they turn into 25 and 19. So the adjuvant is 2, 19, 25, 7. All we have to do is multiply it into the inverse, which is 15. So multiply 15 into this, the adjuvant matrix, and that should give us the inverse of the matrix, which is 4, 25, 11, 1. And to prove it is the inverse, we multiply the matrix into the inverse, and that should give us the unit, our identity matrix. And now we use it to decipher the message. So the matrix times the first step, P is 2515. But to find that, you can down to it gets 7, which is hey. And the same matrix into the two numbers, 0 and 15, and that gives us L and P, hell. And as you can see, guys, this is not a monoalphabetic cipher either. This is a very good cipher.